Well, Kellen, if you're ready to go, if you don't mind kind of just doing a quick introduction, I guess we'll go ahead and get started.
Sure. Well, hi, everybody. Thanks for attending. My name is Kellen Damon. I work with the Marin County Community Development Agency. And the county participates in the BayREN program, which stands for the Bay Area Regional Energy Network. And we're going to get into a little bit of what BayREN has to offer later. But basically, it's the 9 Bay Area counties working together on energy efficiency programs. Russ's presentation is originally coordinated by the Codes and Standards program. So usually we go out to building departments and do trainings on Title 24, Part 6 energy code. And we decided that since heat pump water heaters are, a fast and growing, segment of the marketplace, we'd open that up to contractors. So that's what we're doing here today. So again, thanks for everybody for attending.
Great, thanks, Kellen. Hi, everyone. My name is Russ King, and I work for CalCerts, the home energy rating system provider. And this class today is heat pump water heaters for contractors and installers. I'm assisted by Jeremy Wickstrom, our director of training. We'll be running the Zoom stuff in the background. I should forewarn you, I'm not a plumber and I'm not an electrician, so don't ask any really tough questions. I'm a mechanical engineer with a lot of HVAC design and an expert on the energy codes. And we're presenting this class because, as Kellen said, it's a little unusual for most of our classes that deal primarily with the California Energy Code. And this class is more about a new technology that's out there, heat pump water heaters. We'll certainly talk about how it sort of fits into the energy code, and we'll talk about the energy code that that is affected by heat pump water heaters. And obviously the reason heat pump water heaters are such a big deal right now is because there's a lot of incentive programs out there, and there's a lot of reason to start putting these in people's homes. They are very efficient and they do use electricity as opposed to the older electric water heaters that people are used to thinking about, which would be your typical resistance electric water heater. So these are really cool. They're really high tech. They are a bit more expensive, but they're definitely worth it. So we'll talk about some of those things. My slides to advance here. Go. So just some real quick Zoom meeting how-tos. If you're not a Zoom aficionado, you guys don't need a camera. Please mute yourself. As far as questions go, we'll stop a couple times during the slide presentation to answer questions. If you have a really pressing question during a slide, go ahead and use the Q&A function, or there's a raise your hand function and Jeremy will let me know. We'll break for questions periodically. I have a few slides where I actually remind myself to stop. If you kind of hover your mouse over your screen and click on your screen, you'll see some of these little controls pop up. So there's the mute button. Be sure to click it. So there's a little red slash through that microphone. That means you're muted. There's a Q&A button and a raise your hand button that you can use as well. And then towards the end, we'll be taking a little, it's a quiz, but you won't be graded on it. It's called a poll. The feature in Zoom is called a poll. Just to kind of test your knowledge and make sure you were kind of paying attention during the talk here. And then, like I said, at the very end, we'll also open it up for more questions. And I'm happy to stay around as long as people need to answer questions. If for some reason we don't get your question, we'll give you some email addresses. Or if you come up with questions after today, we'll give you some email addresses where you can certainly contact us. All right, so quick introduction. Kellen, why don't you go ahead and give a brief overview, and I'll advance the slides for you.
Sure. So I touched on a little bit of this, but the Bay Area Regional Energy Network is the 9 Bay Area counties working together on energy efficiency programs. The Codes and Standards program is what does most of the trainings. There are a number of trainings available. If you go to the BayREN Codes website, right there, bayrencodes.org, looks like we have one on December 2nd coming up on quality installation. And one thing we're going to talk about too is the Home Plus program. So that is the rebate program for homeowners that are making these improvements. And, that can be anything from smart thermostats, installation, HVAC upgrades. But for the purpose of today, I just wanted to highlight quickly the The BayREN program provides $400 in rebates for switching from a regular gas water heater to a more efficient gas water heater, and $1,000 in rebates for switching from a regular gas water heater to a heat pump water heater. And also the Home Energy Score program is something we'll get into later. I think there's another slide on that. So can we advance the slides one more? Okay, so this is Home Plus. Like I said, it's a rebate program for homeowners. In order to offer rebates as a contractor, you need to sign up with the program, which involves sitting in on some webinars and filling out some paperwork. It's free for contractors to join, so you don't need to worry about paying any dues or anything like that. And really, some of the other benefits include all the marketing that the counties are doing in the 9 Bay Area counties. So we're really trying to drive demand to BayREN contractors so they can do this work and offer rebates to their customers. There's another cool service called the Home Energy Advisors. So people can call them up. They're part of the BayREN program, and they're just there to kind of answer all their questions about home energy improvements, how to navigate the rebate programs. So if you don't have time or you want someone someone that you're working with to, get a second opinion or talk to, someone who's kind of a third party energy expert, that's a good service as well. And can we advance one more? There we go. And then Home Energy Score. I wanted to shout this out too, just because I know that some contractors use this kind of as a referral service. Basically what it is you go into a home and do a home energy score, which is kind of taking the specs of a home. It should last about an hour or two, depending on the size. And based on the information that you put into the system, it spits out a number between 1 and 10 of how efficient the home is compared to other comparable size homes. And you can also make recommendations on what homeowners can do to improve that score, i.e. make it more efficient. And there's a $200 rebate for each home score. So some contractors actually use this as like a way to pay for their time to go out to someone's home and take an initial look through or inspection before they actually start doing any work. So I just wanted to shout that out. There is an enrollment process for Home Energy Score 2, and the contact information and websites are going to be available. And also you can let us know if you have any questions. And that's just more on Home Energy Score. Looks like it's up to $400 in rebates. But yeah, 200 for sure. I think there's a couple add-on programs to get it up to 400. And yeah, that's it for BayREN, I think. There we go.
Great. Awesome. Thanks, Kellen. All right, so today's learning objectives as far as the heat pump water heater class goes. So we're going to learn some step-by-step actions needed to replace a gas water heater with a heat pump water heater. We're going to kind of go through an example of the steps involved in that process. It's definitely different than just a like-for-like swap out of a water heater. We're going to be familiar with the benefits of electric heat pump water heaters. We're going to understand the energy code requirements for water heaters in general, particularly replacements, because that's going to be the most common type of water heater project that you'll be dealing with, is just replacing an existing water heater with a different type of water heater. And then we're going to learn to appreciate the importance of getting a permit for replacing water heaters. Today's agenda: heat pump water heaters. I'm going to minimize that screen there. So talk about some of the specifics related to heat pump water heaters. We'll talk about the 2019 Energy Code requirements. If you're not familiar with the California Energy Code, it changes every 3 years. It's called Title 24. It's actually Title 24 Part 6 is the correct term. We are in the current cycle, which is the 2019 Energy Code requirements. It took effect on January 1st of this year. And then we're going to talk about some step-by-step installation details. We'll talk about best practices. We'll have a real quick quiz, and then we'll give you some more resources and have a Q&A session at the very end. We're scheduled to go until about 4:15, if I'm not mistaken. And this is the first time we've taught this particular version of the class. So I'm going to go a little quick just to make sure that we don't run out of time at the very end. And we'll stop and have questions or a place for you to ask questions. All right, so you should have been mailed some handouts. If not, let us know. We can send you a link to those. Those include a heat pump water heater assistance sheet, a residential water heater alterations permit guide, and then a regional heat pump water heater incentive guide for contractors. Okay, so you should get all that information. And then you'll get copies of these slides after the training, okay? All right, so let's talk about heat pump water heaters. As you probably know, they've been around for a long time. I didn't realize this. They've been around since the 70s. They just didn't get any traction for a variety of reasons, but they're definitely making a comeback right now for a lot of reasons. But the current market, basically, all the major manufacturers do manufacture some sort of heat pump water heater. There are a few companies that kind of specialize in heat pump water heaters, like Sandin. Their heat pump water heaters are pretty unique, very efficient. As far as the size goes, they're very similar to a regular storage water heater, 40 to 80 gallons. As far as electricity, they draw about 1,300 watts. Okay, like a blow dryer when they're running, they about the same electricity as a blow dryer. An electric resistance element, when that kicks on, will typically draw quite a bit more than that. So they do, when they are running, they draw a lot less electricity in heat pump mode. Most of them have electric resistance backups, and when that kicks on, it'll pull 4,000 to 5,000 watts. Okay. There are two basic styles, if you will, of heat pump water heaters. There's the integrated, where the heat pump and the tank is all kind of one piece. And then there's the split system, which is the storage tank sits in one location, and then the condenser and the heat pump unit is separate and kind of sits outside or wherever you want it to go. We'll talk a little bit about where you can install these. That is a consideration of where you can install heat pump water heaters, because in order for them to work, they need a good flow of air. That's where they get their heat. They extract heat from the air. And so in order to do that, they need a good flow, a good supply of air to pass around them so that they can extract that heat. So on an integrated heat pump water heater, just some features. There's going to be the heat pump unit that sits up on the top there. You can usually tell those by the little louvered vents that allow air to pass through. You'll see those on the right-hand side of this particular one. You see those louvers up there. There'll be some sort of control panel, a little digital control panel, as opposed to the older style water heaters, like a gas water heater that's just got a knob with a dial on it. These are pretty sophisticated. There's definitely a geek factor that goes along with heat pump water heaters. As I mentioned, there'll be those little air vents on the side so that air can pass through. They don't always have to be on the side. They can be on the side and the top or some combination. But the point is air has to pass through there. That's where they're getting their heat, is they're actually extracting heat from the air that circulates around it. There will be some sort of large storage tank. There will be an electrical connection and no gas connection, okay? So those are kind of the features of a heat pump water heater, of an integrated heat pump water heater. Now, as far as the split system, the split heat pump water heaters, the heat pump is separate. It's a separate unit. If you're familiar with a ductless mini split or a mini split like a Fujitsu or a Mitsubishi mini split, it looks just like that. It's a little suitcase style condenser with a fan in it, and what it does is just like a mini split heat pump that does space heating. It's extracting heat from the air. Okay, now the nice thing about these is that you can basically put the tank anywhere you want to, but there will be a refrigerant line. If you look up in the right hand corner here, you'll see the outdoor unit and the tank. There will be refrigerant lines, just like a mini split heat pump for space heating, connecting those two units. Okay. So no heat pump on the top. There is a condenser, is a separate component, and then there will be refrigerant lines passing through from one to the other. Okay, so that's how you identify a split system. These can sometimes be confused. There are certain types of solar water heating systems out there that have just a plain storage tank that looks kind of like this, but really the identifying feature on these is the refrigerant lines coming out of them. Okay, the copper one will be insulated copper lines coming out of them. Quick note regarding efficiency ratings. For many, many, many years, we used something called the energy factor, the EF energy factor. Well, the Department of Energy is switching over to a new type of number, a new type of rating to use called the UEF. And it's basically just a slightly different way of testing water heaters to get an efficiency. It's different than the energy factor. A single water heater could have both a UEF and an EF. They will be different numbers. They believe that the UEF is a little bit more realistic and it does a better job modeling efficiency of a water heater when it's under actual real use. Okay. If all water heaters have UEFs, it allows you to compare similar water heaters to each other to say, oh, this one's, you know, that much more efficient than the other one. It is replacing the old energy factor. They're trying to get rid of that. All water heaters manufactured after a certain date, which is June 17th, will have a UEF rating. Anything before that will have an energy factor. Okay. There's no real one-to-one correlation between an energy factor and a UEF. Some are lower, some are higher. It just kind of depends. It depends on the features of the water heater and the type of the water heater. So it's not like you could just take the energy factor and multiply it times a factor to get the UEF. It's actually a different test methodology. And so it varies. NEEA, NEEA is the Northwest Energy Efficiency Alliance. They are the people who have sort of been delegated to develop water heater specifications for testing of heat pump water heaters. It's a collaboration of all the Pacific Northwest organizations and utilities and laboratories and stuff like that. And they fund energy research for developing new types of water heaters and advancing water heaters. But they're kind of like the AHRI. What AHRI is to air conditioners and furnaces, NEEA is to heat pump water heaters. Okay, they're the ones who test them. They develop the test protocols, and they're the ones who issue the efficiency ratings on various heat pump water heaters. So that's where you'll go to find something. If you want to look up a heat pump water heater to find out what the efficiency is, you'll go to the NEEA products list, the qualified products list, and they have 3 basic tiers for the different sort of levels of efficiency for heat pump water heaters. And it's not just efficiency. If you look down here, you'll see tier 1, tier 2, and tier 3. They do have certain efficiencies. So tier 1 is a 2, tier 2 is a 2.3, and a tier 3 you have to be at least 2.6. But there's also other features that they have to have in order to hit those tiers as well. Okay, and that'll come up in a little while because one of the requirements will say if you're going to replace this kind of water heater, you have to either do it with a tier 1 with all these features or a tier 3 and you don't have all those extra features. So that's why this tiers are important here. So some of the advantages of heat pump water heaters, first of all, they're very efficient. If you compare them to other types of water heaters, using the new UEF, gas storage water heaters are in the 0.59 to 0.69 rating. That's an efficiency rating. So 59 to 69% efficient. Gas tankless water heaters, instantaneous water heaters, are 82 to 95% efficient. Electric resistance water heaters are 99% efficient. That's very efficient, but the problem is they're using electricity, and electricity is very expensive when you look at it on a BTU per BTU basis. Then you get to heat pump storage water heaters, and you're getting efficiencies of 200 to 340% efficiency. How is that possible? How can you be more than 100% efficient? Well, heat pump water heaters cheat, if you will. They cheat a little bit. They're not actually making their own BTUs. So whereas an electric resistance water heater takes electricity and converts that electricity into heat, heat pump water heaters steal BTUs from the air. So the electricity that they do use is not converting to heat. It's taking heat from the air by compressing and expanding refrigerant. So it's actually a much more way to gather heat as opposed to creating heat from scratch. Now, again, in order for that to work correctly, they have to have a good supply of heat. So they need air. The warmer that air is, the more heat there is in it, and the easier it is for it to extract heat from it. But you can extract heat from very, very cold air. It just has to work a little bit harder. So the warmer the air is, the more air you can circulate through it, the better they work. Okay, so they actually are more than 100% efficient. Now we can compete with gas, okay, for cost effectiveness. So it depends on where you are, it depends on your rates and things like that. but now we can start competing head to head with gas in terms of cost effectiveness. They're environmentally friendly. There's no fossil fuels, no fracking, no drilling, no pipelines, and all that things associated with natural gas and even propane. There's a lower carbon footprint. They can be powered by renewable energy. The solar panels on your house, wind generators, things like that can power these heat pump water heaters. The electricity that's used in most California homes is a high percentage of renewable and green sources. So there you go. And then safety. Safety is a big deal. If you've ever taken any like BPI or combustion safety testing, and they teach you how to test gas water heaters for backdrafting and spillage and all that other stuff for the carbon monoxide that's coming out from the flue vents, there's none of that. There's no gas. There's no gas leaks for explosion. You don't have to worry about venting, so there's no penetration through the roof for leaks and things like that. No carbon monoxide. And then no flame, no explosion risk potential for, storing gasoline next to it in your garage or things like that. Okay. Some other advantages: they're Wi-Fi connected. If you've ever had the opportunity to play around with a Nest thermostat or anything like that, where you can call it up on your smartphone and change the temperature in your house. A lot of these heat pump water heaters are Wi-Fi connected, so you can actually call them up on an app on your phone and set the temperature. You can see how much it's been running and things like that. So very super precise temperature control. And by the way, that the whole geek factor with the Bay Area, the very tech savvy region that we live in, that the Bay Area is, this is actually a big selling point for people to be able to call up their water heater on their phone. And then the other interesting thing is, heat pump water heaters, a byproduct is cool air. Because they're extracting heat from the air around them, when you extract heat from something, you're essentially cooling it. So when you extract heat from air, the air gets cold. And so what comes in is warm air, what comes out the other side is cold air. So if you can take advantage of that and use that cold air to maybe cool your garage on a hot day or a sunroom or something like that, by all means, take advantage of it. A lot of the Bay Area tends to be fairly cool, so maybe that's not the best thing, but certainly in the warmer climate zones, it's a good thing. And then, of course, heat pump water heaters, rebates. They are, a lot of these BayREN programs and things like that are really, really encouraging people and basically, in some cases, buying the water heater for you to put in, okay? So that's great. Take advantage of those for sure. So some of the installation requirements and considerations, most require 240 volt, 30 amp supply, okay? Some of the newer ones are getting down into 15 amp circuits, and then hopefully pretty soon, or supposedly coming soon, they're gonna start having some 115 volts, so we don't have to worry about taking up so much room on the electrical panel. Heat pump water heaters require a certain amount of volume of just air, a certain volume of air that they can extract heat from, or ventilation where air is passing through. As far as volume, this is not a code requirement. This is mostly what manufacturers suggest, is that about 750 to 1,000 cubic feet is what they need to work well. And that's actually less volume than say a one-car garage. So if you have a one-car garage, this will work fine. The other thing is if you can provide vents to let air pass through. So you can put these in a small room or a closet as long as there's good ventilation of air, that air can pass through and sort of refresh itself. You don't want to put these in a very confined space. It's because the air will get colder and colder and colder, and pretty soon the air is really cold and the water heater is really struggling to extract heat from that air, okay? You do need a condensate drain. And then the other thing is typically replacing a gas storage water heater with a heat pump water heater, you will usually put in a slightly larger storage, okay? If you're replacing a 30-gallon gas storage water heater, you might want to go to a 50-gallon heat pump. If you're replacing a 50-gallon gas, you might want to go to an 80-gallon or something like that. And the reason is they don't heat the water quite as fast. So you need a little bit more water there as a source of hot water so that it doesn't run out quite as fast. They do have electric resistance backup, so it's not out of the question that you can replace like for like. It's just that you may end up running more on that electric resistance backup and not saving quite as much energy as you could if you had a bigger one, okay? And then one other thing that's kind of a minor deal, is they do give off sound. They do make noise. They sound kind of like those little small refrigerators, like a dormitory refrigerator, because they do have a little compressor that runs, and there's a little fan that runs inside there. So that might be a consideration that you have to worry about. Okay. All right. So let's talk about heat pump water heaters and the energy code. But before I do, are there any questions?
Yeah, Russ, I was going to tell you we do have a question in the Q&A.
Okay. Let me see. How does this electrical equipment work during PSPS events? I presume you mean when they shut off power for, well, just like any other electrical equipment, they shut off the power, it shuts off. But the other nice thing is these work very well if you have like a house battery or a backup generator or anything like that. They will work like that. But yeah, like any other electrical, when they're shutting off the power for safety reasons or whatever, just general power outages, they do shut out. But they do typically have a much larger tank on them as well. So you'll have a much larger supply of water than you would if you had, say, a smaller electric resistance water heater or something like that. As far as when and what companies will be offering the 115, I honestly don't know. I've just heard from several places that those are in the works. New companies are coming out almost weekly with new technology on this stuff. So I would just Google it and find out. Yep. All right. Did we get them all, Jeremy?
It looks like there's one in the chat as well.
Oh, in the chat. Let's see here.
Or I guess a clarification.
Oh, calling for. Yep. Many gas water heaters also do not work in power outages. Yes. Yeah, there are a lot of like direct vent water heaters, power vent water heaters that are gas that they'll shut off too. A typical basic heat pump, naturally vented gas water heater will still work. But there are some that have little fans on them and things like that won't. So yeah, that is definitely an issue. Okay.
And then one more in the Q&A, Russ.
Can the air output from the heat pump be ducted to an attic? Absolutely. Yeah, that's a great idea. In fact, if you have room in the attic and if it's structurally sound, you can put the entire water heater up in the attic. That's actually a very good place to do it because even in the wintertime, attics can get warm from the sun beating down on the roof. The attics can still get warm even in the wintertime, and that's a great source of heat. I'm not sure if you can put a split system like the one in the photo here. If you can put that condenser up in the attic, I think you can. I would certainly look into that, but that might be a good opportunity as well. And then it cools your attic for you too. I know out where we live out in the Sacramento area, that's a big deal for us. Awesome. Okay, let's press on. So energy code, 2019 energy code, as it relates to heat pump water heaters. The first thing you need to know about the energy code is that it breaks California up into 16 climate zones. And in the Bay Area, there are 5 of them, climate zones 1, 3, 2, and 4, and 12. 1 is the coolest one. You'll see that's up the northern coast there. Climate zone 3 is kind of the greater Bay Area, if you will. It's a very marine climate. Climate 2 and 4 are sort of transitional. You definitely get some hot days in Santa Rosa. You get some hot days in San Jose and east of San Jose. And then climate zone 12 is actually where we are over in the Sacramento Valley. It's hot. It's cool winters and hot summers, okay? So you got to know which climate zone you're in. It does vary, not so much for heat pump water heaters, but a lot of the other codes, energy code aspects vary a lot by the climate zone that you're in, okay? Then as far as how the code applies to various things, the energy code sort of depends on the scope of project, okay? And when we're talking about projects that deal with residential water heaters, these are the basic types of projects that you're going to deal with. You're going to deal with a replacement. So that's an existing home that's got a water heater in it, and you're going to put a new water heater. You're going to replace that old water heater with the new water heater. And when you do that, you can either do a like for like. So if you've got an electric resistance and you're replacing it with an electric resistance, you can do that. Or if you've got a gas storage and replacing it with a gas storage, you can do that. The other thing you can do is you can replace a gas storage tank with a tankless water heater. That's one. And then you can switch fuels. You can go from gas to electric. So those are the basic types of, and those in the energy code, those are referred to as alterations, okay? And that's what we're going to focus on mostly today, because that's probably, in terms of sheer volume, that's the most common type of water heater project. But there are some other ones too. You can add a water heater to an existing home. So you've got one, and the people living in the house have decided that one is not adequate, and maybe they can't get heat way over on the far side of the house. So they're going to put a little tankless water heater over in the master suite or something like that. So that's adding a water heater. That's also called an alteration, but instead of replacing a water heater, you're increasing the number of water heaters. Let me put it that way. The other thing that can happen is you're adding onto the house. You're adding a wing onto the house, or you're conditioning the garage or something like that. That could also involve adding a water heater. Whenever you make the house bigger, that's called an addition, and that has certain code requirements that go along with it. And then, of course, last but not least, new construction. You're building a brand new house from the ground up. It's going to have a water heater or 2 or 3 or 4 in it. And that's called new construction. That has its own set of rules that apply to water heaters. Okay. So knowing those different kinds of projects, that's how we're going to kind of organize our discussion about the energy code. And then, of course, we're going to focus mostly on water heater replacements. Okay. The other thing to know about the energy code is there are different compliance paths or compliance options. Depending on the complexity of the project, if it's a really simple project, just a replacement or an alteration or maybe a small addition, you can do what's called the prescriptive approach. And it's basically just a list of things. Follow this list and you will comply. Okay. There's no design flexibility. It's very common for alterations, change outs, and smaller additions. The other option that gets much more complicated really quickly is called the performance path. And that's where you actually model the house. You use a computer software and you model the house. This is very common for new construction. The vast majority of new construction projects use the performance path. You hire an energy consultant, they create this model, they model the house, you start putting all these energy features in there, and the software basically tells you whether it passes or not. The nice thing about that is you can trade things off. So in the prescriptive path, you follow the list. In the performance path, you do a computer simulation. Now, above both of these, you'll see the gray bar up there. Over sort of the umbrella over both of those options are mandatory measures. Those are just things you always have to do. You cannot trade off mandatory measures by using the performance path. Okay. So with that little bit of background, let's talk about the specifics here. Permitting issues. So building permits are required for any water heater that is installed, removed, or replaced. That's pretty much standard throughout the building code, the plumbing code, and things like that. Is you need to get a permit. They're required to get a rebate. Okay, that's important. And when you apply for your permit, if you're not real familiar with the energy code, you're going to want to get familiar with these terms. There's the CF1R Certificate of Compliance and the CF2R Certificate of Installation. There's a third one called the CF3R, but that's mostly for HVAC kind of stuff. There is no CF3R for water heaters. The CF3R is a third-party inspection, okay? So CF1R is Certificate of Compliance. That's what you're supposed to do. The CF2R is a Certificate of Installation. That's what you did. That's to document that you met the requirements of the CF1R. Some building departments may require, in addition to those forms, a schematic layout of the electrical requirements if you're adding a bunch of circuits and things like that. If you're replacing a gas water heater with an electric heat pump water heater, you're gonna have to run some new lines. They may require sort of a plan or at least a schematic showing what you're gonna do with that. Installing equipment without permit exposes the homeowner to liability and insurance risk and is a direct violation of CSLB laws, okay? So alterations projects, mandatory measures. So we talked about the different types of projects, alterations, additions, new construction, and then we talked about prescriptive, performance, and mandatory measures. So now we're going to focus on alteration projects and mandatory measures that apply to those alteration projects. So this would be a change out. This would be replacing an existing water heater with a new water heater, okay? So here's the code section 150.2 B1H. Memorize that. No, I'm kidding. You don't have to memorize it, but you do need to know that pipe insulation, insulating the pipes around a water heater, is a very important energy feature. A lot of energy is lost through the pipes. Okay, so if you're replacing a water heater, what it says is all newly installed piping, the insulation requirements of section 150.0 J2 must be met. So any newly installed piping must be insulated. We'll talk about what those requirements are in just a second. And then it says any existing accessible piping must also be insulated to a certain level. Okay. Now this is kind of interesting. In the energy code, in this section, it says 1, 3, and 4. That's actually a typo. When they changed the code, they forgot to change these little numbers. It should say 1, 2, and 3. So just be aware of that. So the requirements are, and remember, this is all new pipes being installed. So if you're running a new pipe because you've moved the water heater or whatever, or any accessible existing pipes have to be insulated. The first 5 feet of cold water pipes from the storage tank. So the cold water pipe coming off the storage tank, the first 5 feet of that has to be insulated. All hot water piping with a nominal diameter equal to or greater than 3/4 of an inch and less than 1 inch. Okay. So all the bigger pipes, accessible pipes, have to be insulated. All hot water piping with a nominal diameter less than 3/4 of an inch, that is part of a recirculating system. So it's got a pump on it that goes in a loop and comes back to the water heater. That has to be insulated. From the heating source, from the water heater to the kitchen fixtures, any accessible pipe has to be insulated. That's a mandatory measure. Okay. From the heating source to a storage tank or between storage tanks. So I mentioned sometimes there's a storage tank, like from a solar water heating system. It's sitting next to the regular water heater. Any pipes that go between those have to be insulated. And then any buried pipe below grade. Now, if it's an existing house and it already has buried pipe, that is not accessible, so you don't have to insulate that. It's only accessible piping. Now, the definition of accessible is kind of up to the local building department, but it's basically if you can get to it without too much trouble. If it's up in an attic, if it's in an accessible crawl space, and it's right there where you can put pipe insulation on it, that's usually considered accessible. If it's buried, if it's inside a wall that's sheetrocked, you don't have to rip the sheetrock off. That is not considered accessible. Okay, so there you go. All accessible pipes must be insulated that meet these requirements here. As far as the actual insulation goes, once you determine that the pipe needs insulation, this is how you insulate it, and this comes out of the plumbing code. The insulation shall fit tightly to the pipe, shall fully cover all elbows and T's. Corners, elbows must be mitered, T's must be notched. All pipe insulation seams must be sealed. That's usually a caulk or a glue or a tape. No piping should be visible due to voids, with the exception of the last segment of piping that penetrates the walls or right at the sink or whatever. You can have that last little bit be exposed, but pretty much everything else needs to be covered. Installed piping may not be located in supply or return air plenums. Hot and cold water piping installed in parallel runs should be at least 2 inches apart from each other. You don't want hot and cold pipes touching each other because they will transfer heat. That's not good. If a firewall interrupts the first 5 feet, then the insulation can stop on one side and then continue on the other of a firewall, like in an apartment or something like that. Pipe completely surrounded by wall, floor, or ceiling insulation does not require additional insulation. So if you've got pipes running through the attic and they're buried under blown-in insulation, or maybe you have fiberglass bats tucked around them, you don't have to insulate those. That is insulation on those pipes. Okay. All right. So that was mandatory measures. Now let's talk about alterations projects, prescriptive measures. And prescriptive measures are like a checklist, and there's some options. You can pick from this list or pick from this list. You usually have a little bit of options. They're not always mandatory, but here's an example. So if no natural gas is connected to the existing water heater location, okay, so you've got a house, you've got an existing house, and it's got an electric water heater in it, then if you want to replace that water heater, any electric water heater, including heat pump water heater, is allowed to be replaced there, okay? And this is interesting because in the previous code, it didn't say natural gas connected to the existing water heater. It said natural gas connected to the house. And so that actually caused a lot of problems, because you can have a house that had an electric water heater over here and the gas comes over to the other side of the house where the furnace is. If that was being considered connected to the house, well, they cleaned up that language and made it a lot more reasonable, that says that that gas has to be connected to the water heater, okay? And this is if no gas is connected to the water heater. If there's no gas connected to the water heater, any electric water heater will do, okay? Now, if there is gas and it is connected to the existing water heater and the new water heater is going into that location and you can connect to it, then the prescriptive measures have some choices, okay? There's some things you have to take into consideration. And there's two basic options. If you want to replace with a heat pump water heater, there are two basic options. Option one is installed a base efficiency. In other words, the cheapest heat pump water heater you can legally buy, tier 1, tier 2, okay? You can do that, but they're not as efficient. So you're gonna have to do a few extra little things to make them up, sort of bring them up to the cost effectiveness of a gas water heater. So a base efficiency heat pump water heater has to be sitting on a special insulated pad. Okay, it's an R10 pad. I personally have not seen one of these, but apparently they're out there, and it prevents heat from conducting down the water heater. If you're replacing it on a box, if the water heater that you're replacing was sitting on a box and you're replacing it up on top of that box, that's fine. They just don't want it to sit right on the concrete. All right, then the other requirement for the base efficiency is a special communication interface that allows utility control for grid integration. One of the other interesting things, really interesting things about heat pump water heaters is if the homeowner voluntarily allows them to be controlled by the utility, okay, the utility can use them like a battery. And when there's excess power generation during the day, they can send that to these water heaters and actually change the set temperature in these water heaters as a place to sort of equalize the grid. And that's very interesting. So the water heater has to have the ability to do that. It doesn't have to be hooked up to the utility. It just has to have the ability to do that. Okay, so that's option one, base efficiency with an insulated pad and the ability to hook up to grid integration. Or you can skip all that other stuff and just put in a tier 3 water heater. So those are your choices. Base efficiency with the extra features, or go to the tier 3 higher efficiency heat pump water heater, and there you go. The other thing you realize is the requirements say that you cannot install these outdoors, is what it says. Obviously, you wouldn't just like set this on the side of the house where it would get rained on and stuff like that. But outdoors also means like a covered patio or a covered carport that's exposed. You're not supposed to put them there, but you certainly can put them in an enclosed garage or an exterior access closet or something like that, assuming it has that circulation that it needs, okay? Let's talk real quick about new construction and addition projects, the mandatory measures. Before we do that, any questions we need to answer before we move on? Jeremy, do we have any?
Looks like right now there's none.
Awesome. Okay. A bunch more people showed up too. That's great. Good turnout today. Thank you, everybody. All right. So new construction and additions. So we're building a new house or we're adding on to one. These are the mandatory measures. And as what you'll see real quick is they're basically the same as what we talked about before. All the pipe insulation stuff that we talked about. But here's the deal. In new construction, all pipes are considered accessible because they were installed newly. So you can't say, oh, I already buried this pipe underground, it's not accessible. Nope, at one point it was accessible. So you do have to insulate buried pipes in new construction. All those other things we talked about between the water heater and the kitchen, pipes greater than 3/4 of an inch. What was the other one? Buried pipes, and then pipes in a recirc system. Those all have to be insulated in new construction. They are considered accessible and have to be insulated in new construction. And then additions, it just kind of depends. What are you running out to that addition? Does that addition have a kitchen in it? Does that addition have a water heater in it? Does it have a sink or anything like that? So that would just kind of depend. Looks like we got a question pop up here real quick. Let me get that one. Nope, just a chat. All righty. Did I go too far? Construction, pipes. Okay, here we go. In new homes or additions with gas or propane. Now this is kind of interesting. In new homes and additions where you're adding a gas or propane water heater, you must provide adequate electric capacity for future heat pump water heaters. Okay, you have to basically stub out, because the best time to plan for the future is when you're building something new. And you say, okay, I want a gas water heater now, but I may eventually put solar panels on my roof and I may eventually want to switch over to a heat pump water heater. So the most cost-effective time to do that is when you're building that house or adding on to it. So if you're building a house or adding on to one, and that includes adding a gas or propane water heater, you must provide, basically make it easy to add a heat pump water heater in the future. That includes a dedicated electrical circuit. And I won't go into all the details, but you can read this later. But you have to have a certain size copper branch circuit, certain gauge, must come within 3 feet of the water heater, stuff like that. Both ends labeled as spare, and a reserved single pole circuit, future 240 volt use has to be labeled. And then there's also, the Energy Code has had this for a long time in new construction. If you install a gas storage water heater, they also want you to have the ability to upgrade to a tankless water heater. So they want you to oversize the gas for a storage water heater to upgrade to a tankless water heater. And then you also have to have the ability to upgrade to a heat pump water heater. Okay. Here's a question.
Looks like we have a question. Yeah.
Got it. Can a C36 plumbing contractor run the glycol lines set for outdoor condenser? In the past, yeah, I have an HVAC license. I actually don't know the answer to that question. That's a CSLB question. And that brings up a really good point, that servicing a heat pump water heater, because the heat pump water heater has refrigerant in it. So you do have to have special requirements, special certifications to service it. As far as the glycol lines, that's actually not, sorry, that's not a heat pump water heater. I think you're thinking of for the solar panels is typically where they use glycol. For the heat pump water heaters, if it's one of those split systems, you'll be running refrigerant lines. So it'll have, what gosh darn, I can't remember, not R22, that's the old stuff. R134, gosh, I'm drawing a blank. I should know this, but it's refrigerant. So you have to have the EPA certification to do it. So yeah, that you are starting to get into a sort of another trade now when you start talking about refrigerant and stuff like that. So that's a good question. But I'm actually not sure about the glycol stuff. That's usually a heat transfer fluid for the solar water heaters and solar panels and stuff like that. Okay. Let's see, we got all that. New construction and addition project prescriptive measures. So what we just talked about was mandatory measures. Now we're talking about prescriptive. This is where you kind of have a choice between what you want to do. And it's very similar. There's 2 options for if you want to install a heat pump water heater in addition without having to run the computer simulation. You can either do a basic heat pump water heater, a base efficiency water heater, and you can either put in what's called a compact water distribution. That's a specially designed water distribution system where all the runs are very short. Okay. And then put in something called a drain water heat recovery system, or you put a little extra solar on your house. Okay. So that's option 1. And then option 2 is to put in the tier 3. And then in climate zone 1 and 16, 16 is up in the mountains like Tahoe and stuff like that. Put in a little extra PV. Okay, or do the compact water distribution system. So depending on the efficiency of the water heater, whether it's a high efficiency or base efficiency, it just has a little extra features. And then here's where the climate zones kind of come into play as well. Okay, so new homes and additions. Heat pump water heaters can also be modeled. So the performance approach, absolutely, you can model the heat pump water heater and get good credit for that. Basically, in the performance approach, you're using certain energy features to kind of trade off other energy features. So if you have a really high efficiency water heater, you can trade that off against, maybe a little bit less ceiling insulation or less efficiency air conditioner or something like that. So absolutely, the heat pump water heaters are modeled very well in the performance approach. Okay. Recirculating system. You might occasionally get a homeowner asking you to add a recirculating system. Those were popular in some older homes where the water heater has a long ways to go for water to get to the other the fittings in the house, and so they'll add a little pump and they'll pipe in a loop, and this pump sends hot water through this loop so that each of the fittings just taps off that loop, and they don't have to wait as long. Well, guess what? Those waste a ton of energy. You're basically heating the pipes in your house. It's like a radiant floor heater, just so you can have hot water coming to to your various. There are some, however, that don't use quite as much electricity, and those are called demand recirc systems. And that's basically where instead of this pump running all the time or on some kind of a timer or temperature control, you actually go into the bathroom, you push a button while you do your business, and then that pump turns on, and then when you're ready to use hot water, it's there. Okay, so those are called demand recirc systems. Those are actually kind of encouraged by the energy code, because not only do they save energy, they save water. So instead of standing there and holding your hand and waiting for hot water to come out and wasting all this water, as soon as you turn on, the water's there, but you're not circulating this water through the house all the time. Okay, so if you want to add to an existing home a recirc system, it can only be the demand recirc type. If you want to install anything else, you're going to have to do some trade-offs. You're going to have to use the performance approach and trade off. And that can be, for an existing home, that can be a real pain to have to create this computer simulation to generate, to see how much, what other things do I have to do to the house to offset this energy use of this really horrible recirc system that I want to install in this house. You just have to trade it off, and you have to prove that it's going to do that. I highly recommend you look into the demand recirc systems instead. Those are allowed, and you can install those without having to run a simulation or anything like that. And by the way, a little bit, I won't go into a whole bunch of detail here, but demand basically means that it has a button that the occupant turns it on and starts the pump. There would be manual controls. They can be located in kitchens and bathrooms. They can be activated by wireless switches if necessary, so they're easy to install. Controls will allow the pump to operate until the water temperature till hot water reaches that point, okay? And it doesn't run for a whole long time. So there's some requirements for the controls of when the pump turns on and when it turns off. The controls shall limit pump operation to a maximum of 5 minutes after operation. Okay, so those are actually, like I said, those are actually quite efficient, and they do save a lot of water as opposed to just standing there waiting for hot water to get there. All right, so just kind of some examples now of heat pump water heaters. This example, this particular one is a GE pump, heat pump water heater. So it requires 10 gauge wire. It requires 16-inch space above the unit. Again, this is just an example. You got to look at the manufacturer specs for whichever one you want to install, but these are the types of things you're gonna have to take into consideration. So 16 inches of space above the unit to get to the filter, 7 inches from the back wall. Make sure it's in a dry and heated location. That gives some examples there for the size of the room, or a closet that has a good louvered air supply. Temperature pressure overflow termination. It requires a condensate line. That's potentially a big deal, and a floor drain for the condensate line, if necessary. Okay, so obviously the electrical can be a big issue. We'll talk a little bit about that. When the heat pump water heater gets installed, the CF1R certificate of installation, remember that tier 1, or sorry, the base efficiency with all these features, or the tier 3, that all goes on to that CF1R certificate. So at the beginning, when you get your permit, you're telling them how you're going to comply, okay? And you're going to say on there, this is the type of water heater I'm going to install. When you do install the water heater, make sure you follow that CF1R. Make sure you meet all the prescriptive requirements. Make sure you meet all the insulation requirements. Make sure you take into account the condensate removal. Do note that the condensate on a heat pump water heater is not like the condensate off of a condensing furnace. A condensing furnace is combustion products that are condensed, and you have to deal with those in a special way. You can't just put them down any old drain. However, with heat pump water heaters, it's pure water. You can basically drain it wherever you want to, just like an air conditioner. You do have to have a visible AC disconnect for service, okay, so that anyone servicing this heat pump water heater can shut it off and they can see it. Make sure no one goes over and turns it on while they're working on the water heater and stuff like that. And then you do require, these are storage. These are very heavy. They have a lot of water in them, so they do require seismic bracing, just like any other storage water heater, okay? All right. I mentioned already, if natural gas is connected, it has to be a tier 3 or meet these other requirements. If no natural gas is connected, then basically any heat pump water heater that meets the federal minimum can be installed. Okay, so the type of water heater, or I should say the efficiency of the heat pump water heater that you're allowed to install depends on whether or not the house has gas to the water heater location. Okay, they're just kind of assuming, well, there's gas here, it would be cheap to hook up a gas water heater, therefore the installed heat pump water heater has to be a little bit more efficient. If they were just going to replace an electric water heater, go for it. Put in a heat pump water heater. Any federal minimum heat pump water heater will do. All right, let's go through real quick. I am getting a little behind on time. If there's any questions at this point, Jeremy, do you have anything?
Nope, nothing right now.
Awesome. Okay, so we're gonna do a real quick and step-by-step installation, just kind of sort of mentally walk you through the process of the kind of things you have to think about. This is just an example, okay? This is not intended to be sort of, this is how you have to do it. This is just an example to kind of, like I said, kind of walk you mentally through the process of what you have to go through. All right, when you replace a heat pump, when you replace a gas water heater with a heat pump water heater. Okay. All right, so converting a gas water heater to a heat pump requires advanced planning and coordination between trades. All right, so we already talked about a great question about the water heater itself. Do you need special requirements to service it or install it or anything like that? I think just to install it, it's pretty much just it's an enclosed unit. You don't have to hook up any refrigerant lines or anything like that. But if it's a split system, you have to set the outdoor unit and the water heater or the tank on the inside. You have to charge the system with refrigerant. So that's a certain trade that has to do that. And then of course electrical. Okay, a lot of water heater replacement companies also do electrical work because they deal with electrical water heaters anyways. But if not, you're gonna have to partner up with a electrical contractor to do some of the work as well. Okay, so coordination between trades. The following steps will be required by manufacturer's instructions and/or local codes. Local codes always supersede any manufacturer's suggestions or recommendations, and definitely supersede these suggestions that we're about to give you. Okay. So step one, find a good location. Heat pump water heaters do make a little bit of noise, and they need about 1,000 cubic feet. Some of them down to 750. Again, basically a little bigger, or sorry, a little smaller than a single car garage will work just fine. Okay. They should be placed in a garage, a basement, or other enclosed patio, so that they operate efficiently. They may not operate as well or pass code if placed inside a closet. Okay, so be sure to check with the manufacturers. Each manufacturer will have very detailed specs on where you can put these things and what kind of air circulation you need around them. By the way, I forgot to mention some of some of them are actually ducted. They'll actually pull air from a different part of the house, use that air and dump it somewhere else. So that's another thing to consider when you're shopping for a water heater. Looks like we got a question here. How are EQ bracing being performed with the 7-inch clearance on the back and blocking? I would just check with the manufacturer. That 7-inch clearance on the back was just that particular manufacturer's suggestions, but you can put blocks back behind it, 2x8 blocks. I've seen things like that. So yeah, check with the manufacturer, check with your local code on how to do that. Let's see, where am I here? Special equipment can be installed to offset the situation, which is kind of what I was talking about. You can put in louvered vents and things like that. So the manufacturers will give you good instructions on that. And then of course, condensate line. Make sure you can figure out a way to get that condensate line outside. It is pure water. You can dump it into a drain. You don't have to worry about it being acidic or basic or whatever furnaces are. Confirm space on the electrical panel. Okay, again, look at the actual unit that you're looking at. This is just an example, 220 volt, 30 amp breaker. There might be some new ones that require less. Be sure to check for those, but you got to check the electrical panel to make sure you got room. Confirm the physical space exists. If space is limited, you can go to the skinny breakers. And in some extreme situations, you might have to go to a larger panel. That's where the cost can really go up. So be sure to check on that, and be sure to make sure you have qualifications to replace the panel if that's necessary. And then shop around. Look at all these different manufacturers. You might work with a specific manufacturer or have a supplier that uses a certain manufacturer. Check with them, shop around, look at all the different features. Look at all the Wi-Fi interconnect features and things like that. Look at the requirements for, are they ducted? Are they split? Are they integrated and things like that? And because you're gonna have a lot of different situations where one might work and one may not. Consider models with connected functionality. That's the Wi-Fi stuff that allow mobile control, okay? And then especially if the house has solar panels, solar electric panels, PV panels, that's a great opportunity to take advantage of that. And they can kind of do the timing of when their panels are producing optimal amount of solar, and they can adjust the settings on the water heater to account for that. It's very cool. Then get your building permit. Many building departments allow the permit to be obtained online or in person. Provide proof of the UEF. Don't always rely on like manufacturers' marketing literature for the energy factor. The best way to do it is actually go to that NEEA website and look up the model number and print out that page from the NEEA website. Okay. You'll probably also need a separate permit for electrical and plumbing work. Okay. If you do not do electrical work, have one or more electricians lined up that you can refer the homeowner to, or partner up with one and do the project together. Step 5, install the electrical system as needed. Obviously follow the NEC. The system will probably require 220-volt disconnect switch. That's what I was talking about. It has to be within view, usually within 3 feet. The last 3 feet can be unsupported metal flexible conduit. Again, talk to the local building department, follow the local codes. Drain and remove the existing natural gas water heater. Okay, so if there's an existing water heater there, you got to drain it, cap off the gas line, and test that gas line for leaks. Okay, just spray a little soapy water on there. If it bubbles, it's leaking. All right, disassemble the flue pipe that goes up to the roof and cap it off. Ideally, if you can get up inside the attic and cap it off underside the roof and minimize the opportunity for leaks and things like that, that's a good way to go. Install the new heat pump water heater. Follow manufacturer's instructions, connect all water pipes, insulate to code, connect the condensate and PT overflow, completely fill the tank while bleeding off the air, observe all connection points, solder joints for leaks. You guys, if you've installed any water heaters at all, you know how to do that. Earthquake the strap per code, verify that the circuit breaker is off, the disconnect switch is open, and then connect the electrical wires per manufacturer's specifications. Once you are ready for operation, turn the power on, close the disconnect switch, turn the breaker, then you got to program the heat pump water heater. It's not just to set it and forget it, okay? Read the manufacturer's instructions. It's not that difficult. They've gotten used to making this pretty straightforward. Put the unit in heat pump mode. As you'll see in a second, there's a lot of different kinds of modes these things come in. Put it in heat pump mode. Most Bay Area weather is warm enough so that it can run in heat pump mode throughout the year. Okay, some of these have separate backup modes for very, very cold climates, like if you're up in Tahoe or in Minnesota or whatever. There's different settings, but the Bay Area is mild enough and is warm enough that you can just leave it in heat pump mode pretty much year round. The only time they may want to set it on a different mode is if they're going to have a very high use, like they have a bunch of company coming over and spending the night, or they've got teenage kids or whatever. Excuse me. Then you might have to put it in hybrid mode, which will switch between heat pump and resistance electric, okay? But start off in heat pump mode, let the homeowner use it for a while. If it's not keeping up for whatever reason, then they can start playing with the settings. And obviously those settings will use a little bit more electricity if necessary, okay? Get your final inspection from the building department. Then go get your rebates. Make copies of all documents required, such as sales receipts, invoice of labor, the building permit, whatever is necessary to get your permit. Make sure you keep all that paperwork. Submit the application and documents. It probably varies from jurisdiction to jurisdiction and the different kinds of rebates that you're applying for, but just be aware that you're going to be asked for all this stuff. Inform the homeowner of maintenance requirements, and probably just maintenance, but operation requirements as well. Read and understand the requirements so that you can train the homeowner, so that if the homeowner calls you with questions, that you can answer those questions. There's usually an air filter which needs to be cleaned periodically, so be sure they're aware of that. As far as controls go, again, follow manufacturer's instructions, set the temperature point if it's not already factory set. Heat pump systems have several operating modes, so this varies from manufacturer to manufacturer, but it's kind of like this. So you have heat pump mode, which is your normal operation, hybrid mode, which switches back and forth between resistance electric and heat pump, and then you might have a boost mode that kicks it into a resistance electric if for some reason they really need the water heater to come back up to temperature. And then there's some other schedules as well. You'll have a standard schedule, and then you might have a vacation schedule as well. So again, if a lot of these have really cool apps that make this really easy, and you can just do it on your phone. Heat pump modes can be set year-round use. If the conditions are right, you just set it and it should be fine year-round. But make sure the homeowner knows that there's things they can change. If it's not keeping up, if they're running out of hot water, there's things they can do that'll make it work much better, and it'll still be much more efficient than what they had before. Avoid using other modes that may use energy needlessly. So make sure they realize that to start off at the most efficient mode and then change if necessary. Don't start at the boost mode, because that's not a good idea. All right. Best practices: always follow safety instructions. Be sure the power is turned off before making any electrical connections. Get a building permit. Make sure the unit is level. Install a unit as close as possible to the end-use fixtures. That's more of a plumbing design issue, really. Install a shutoff valve on hot and cold water supplies. Pretty obvious. Check for leaks. Avoid excessive temperature settings above 120. Okay, unless that grid integration stuff I was talking about, that will actually bump up the temperature if necessary. So the water heater actually kind of acts like a battery. It's kind of cool. Communicate with the homeowner should any complications arise, and communicate to homeowner any special maintenance needs. All right, Jeremy, are you ready for a poll here?
Yes, I am. And there we go.
Sorry to rush. I want to make sure you hit the time limit here. We're quickly running out of time, and I want to give Kellen definitely some time. All right, so on your screen, you can click these buttons. Notice that you have to scroll down to see all of the questions, okay? And I'll read those to you really quick. California Energy Code is triggered. This is a true or false question. California Energy Code is triggered when replacing a non-functioning water heater with another one of the same size and type. Does that trigger the California Energy Code? True or false? Number 2, if a homeowner wants to add a recirculation system to their water heater, the recirculation system must be what kind? Timer temperature controlled, demand controlled, infrared control, or no controls are required. Number 3, a homeowner can replace their gas storage water heater with a heat pump water heater that meets which of the following requirements? Base efficiency on an insulated pad with special grid integration, a NEEA Tier 3, an electric resistance water heater with solar panels, or 1 and 2. Okay. I think that's supposed to be A and B, but so it's A, B, C, and then D is A and B. Number 4, an opening must be made in an insulated wall when replacing a water heater in an existing home to determine if the hot water pipes are insulated. So if you got your pipes going to say a garage wall and you know that wall's not insulated, do you have to open up that wall to insulate those pipes? True or false? And then you'll hit submit when you're done. And I think Jeremy can tell how many people are chugging along there.
Yeah, it looks like we're about 51%, 55%. So we're plugging along here quick. Give it a few more seconds for everyone to answer.
All right. let's go ahead and
All
sorry to
right, we'll
cut
go
you
ahead
off
and
if
hit
anyone's
it.
still working on it. Nobody ever minds if you give them the answers before they're done, though. No one's ever complained about that. All right. So, is energy code triggered when you place a non-functioning water heater with another? Yes, it is. Basically, the answer, if the energy code is triggered, the answer is usually yes. If you're replacing anything that consumes energy, some part of the energy code is going to be triggered, whether it's a mandatory measure or prescriptive or anything like that. If a homeowner wants to do a recirc, it has to be demand controlled. You can technically use the other ones, but you have to do that computer simulation model, that performance approach, and it's probably very expensive to do that. It's probably not cost effective to do that. A homeowner can replace their gas storage water heater with heat pump water heater that meets which of the following? And it was the first two. It was base efficiency on a special pad or a NEEA tier 3. That's that option A and option B. Okay. Which means the answer is the fourth one. Answers 1 and 2. Good job. An opening must be made in an uninsulated wall. No, that is considered not accessible. So you do not have to open sheetrock. You do not have to unbury stuff. That's considered not accessible. You only have to insulate accessible pipes in an existing home. If it was a new home or an addition, then you might have to do that. If you accidentally covered up, you were building an addition, you accidentally covered it up and you went, oops, I forgot. Then you have to open it up because that was accessible at one point. All right, good job, everybody. Some resources for permitting compliance really quick. These are the handouts that you got. They have something called a heat pump water heater guide. That's a great tool. This covers all, this covers heat pump water heaters. So this is specific to heat pump water heaters and kind of gives you a little more specific details getting a permit and the types of water heaters that you can install, and it covers the NEEA website and stuff like that. Then this other one is called the Alterations Permit Guide for Water Heaters. This covers all types of water heaters. And so it kind of asks you, what kind of water heater do you have now? What kind of water heater do you want to replace it with? And it tells you what requirements you have to go through for all types of water heaters. And there's this very nifty online tool, the online BayREN e-permit tool, which is very similar to this permit guide, but it's online. It's an electronic version. It asks you some questions, you answer the questions, and it tells you what you can install, what you can't install. So that's a pretty slick tool. Building departments like to use that to send people to for answers. You can send homeowners to it. You can use it yourself. It's very handy and it's accessible online. And then, Kellen, I think this back to you now. There's going to be a couple slides about the incentive program.
Hey everybody. So I mentioned earlier about the BayREN Home Plus rebate program. There are a couple other programs. There's one that's specific and it goes directly to contractors, and that's for installing heat pump water heaters. So that's another $1,000 that can be included with the Home Plus program. And the website to sign up for that is at the bottom, pretty simple, just bayren.org/HPWH for heat pump water heater. Can we go to the next one?
A slight delay.
Okay, so yeah, this is more information on that. So basically what's going on with this program is BayREN is partnering with MCE Clean Energy and other, what are called CCAs, community choice aggregators, are doing their own programs. So I know a lot of the contractors on the call today are in Marin. So this extra $1,000 incentive is for MCE customers. But as you can see on this, and we're going to be, sending it out, there are some additional rebate programs depending on where people are. And also in Marin, the county runs a rebate program for electrification projects, including heat pump water heaters, and that's called Electrify Marin. The cool thing about this program is usually the rebate is handled by the homeowner. So it's not a lot of extra work for the contractor. You just kind of, need to make sure people are aware of it. And that's another $1,000 plus an extra $1,000 if that person's income qualified. And that can be stacked on top of the two other rebate programs, Home Plus and the BayREN heat pump water heater, contractor incentive for, $3,000 up to $4,000 for income qualified folks. for a heat pump water heater. So that's, you know, a pretty big chunk of the project. So yeah, that's definitely a good thing. And, you know, hopefully this is going to really bring up the market and demand for heat pump water heaters, at least in Marin. And, you know, all these other jurisdictions are doing great programs as well. I think that's it.
Yep, then a bunch of contact information for you guys. You'll be getting a copy of these slides. So there you go. Let's see, there are some additional training coming up. You can go to the Energy Code ACE training as well as BayREN training. There's some websites there. And do we have a last minute question? Oh, no, I don't see it.
We have the training the evaluation at the end.
Oh, that's right. So if you don't mind, if you'd please stick around for just a minute or two and fill out the training evaluation to let us know if this class was useful to you and any ways we can improve it.
Russ, we did get a question on what's the average cost of a install for a heat pump water heater, I'm assuming.
Yeah. The best I can tell you, my experience is mostly in Sacramento in the SMUD territory. And I know that their rebate wasn't their rebate like $3,000 for a while, or was it $2,000? I can't remember. And whatever their rebate was, that covered almost all of most of the projects. It was only when you got into having to replace the electrical stuff that the rebate didn't actually cover the vast majority of the cost. So, Kellen, I don't know, do you have any better information than that? I want to say like between $3,000 and $4,000, depending on whether you have to do electrical or not.
Yeah, I've heard numbers around that. Mark Chabria is the program coordinator for Electrify Marin. He's actually in the chat today. I wonder if he could type in something. But yeah, at any rate, you could follow up with us, and you know we could get you some better concrete numbers on that. Especially if you're in Marin, because Mark sees a lot of rebates across his desk, and he keeps a tally on what people are paying for these projects.
Great. And then on this training evaluation, everyone be sure to realize that you have to scroll down to see all the questions. There's what, 9 or 10 questions down there. And we really appreciate it. We hope you guys are all staying safe. We appreciate your time, and hopefully you'll catch us at a next training.
Great. Thanks, everybody. Little last minute thing. Mark chimed in. He says usually it ranges between $3,000 to $6,000 depending on some factors. So thanks, Mark. These rebates going to the customers or the contractors. So Home Plus goes to the homeowner. Same with Electrify Marin. There's the what we call the midstream incentive, the program that BayREN is working on with MCE. That's a direct to contractor rebate, and that's $1,000. And I've also seen with Home Plus and in the past Home Upgrade, Energy Upgrade, California Home Upgrade, some contractors, because there is some paperwork involved, they might charge a little bit of a paperwork fee in order for the homeowner to get their rebate. So that's one way that I've seen contractors kind of recoup the time spent on applying for rebates. Cool. So I think that's maybe it for questions. We're at about 4:21. So
Someone in the chat said they didn't get an email, so we'll make sure everyone gets that stuff sent back to them.
Yeah, we'll be sending this.
And they
stuff out.
registered. Yep, good deal. All right. All right. Thanks everyone very much. Catch you at the next one. See you, Kellen. Thanks,
Yeah.
Jeremy.
Thanks, Russ.
Thanks, everybody.